Hello everyone, and welcome back to another remote sensing lecture video. And in this lecture video, I want to talk about what happens after you've run your first unsupervised classification. Right, let's just assume that I threw this image into an unsupervised classification and these are the results that I got. Well, what do I do now? Right. So what do you do after your first unsupervised classification? And this is a legitimate question. What do you do next? Well, one of the downsides to unsupervised classifications is that because we didn't tell it anything in the beginning about the image, right, these results don't necessarily know anything about the image either. And so what I mean by that is that once we get the results, right, it is the analyst's job to interpret the results. Right? I'm going to scroll down a little bit. I want to be able to just see that. So interpreting the results, really means sort of two things. One, it means matching the clusters / classes, right? These are the things that the output gave us, right? It's matching those up it's matching these up with the real world features, right? So in this case, we have water, we have beach, we have some urban, and we have some forest and vegetation, right? So we have to pick real world features, right? Surface features that we think are unique and that we would care about mapping and that we feel are reasonable to be able to extract from the image. So the first thing of interpreting these results is figuring out, okay, well, what classes correspond to what surface features? Okay. And so that could mean two things, right? One, well, it could mean three things, right? One class could equal one surface feature. Right, and this is the best possible case scenario. This very rarely happens. Right, but a good example is water will sometimes be a 1-to-1 ratio, where one cluster equals one surface feature. You don't have to do anything. Two, right? We have multiple classes share one surface feature. All right, and if we scroll up just a little bit, right, we can see, for example, forests are probably a good example of that, where we have the yellows and we have the green, different shades of green, right, are all going to likely be forest. So if we have multiple classes that share one surface feature, right, if we have multiple classes that share one surface feature, we typically need to do what's called merge classes, right? And that's where we make multiple classes into a single class. Okay. And then the third option, right, the third option is we have multiple surface features in a single class, right? So if we look up here, right, maybe we really did want to pull out the manicured landscape from the trees, right? Maybe that was a goal that we had. But you can see that one of these, like this green right here, is clearly the manicured golf course. But you can see this green also occurs in other places. And so now we have to make a decision. Well, all right, if multiple surface features, in this case, right, the manicured landscapes and also some of the forested areas are in the same class, we have two choices we can make from here. Right, the first is we can reconceptualize our surface features. Right, maybe that was too much of an ask, right? Maybe we were asking too much. This image just doesn't have the spectral and spatial resolution necessary to be able to separate out the forest from the golf course. Right? Maybe that's too much. And we need to just accept the fact that our surface feature is going to be vegetation. Right? That's one option. Okay. Right. Another option is we do what's called bust classes. Right? And bust classes is where we literally run a separate analysis that separates one class into multiple classes. Right? Maybe if we were to focus in on just the pixels that are in this vegetation class and we rerun the analysis on just those pixels, maybe we'll be able to differentiate between the manicured areas and the forested areas, right? Maybe that's an option. So we can either reconceptualize our surface features, say, okay, well, we asked too much, or we can say we didn't ask too much, but we can run the analysis again and try and bust those classes up. Or a third thing is just accept the error. Right? Maybe it's just a couple of lawns in an entire image that are being incorrectly classified, and we're just like, hey, errors happen, and we make a note of it and we move on. Right, so these are the three choices if multiple surface features are in a single class. We can either reconceptualize what our surface features actually are, and maybe we were asking too much. We can say, oh no, we're going to get this, and we can bust that class up by using a separate, the next step of the algorithm. Or we can just say, hey, we've made a mistake here, but we're going to note the mistake and we're going to move on. Okay? So hopefully that makes sense. Right? Again, if we have one class equals one surface feature, that's great. If we have multiple classes that share a surface feature, we can merge them. And then this one is the tricky one, where if we have multiple surface features in a cluster, how do we handle that? Okay. So hopefully that makes sense. And as always, please reach out. Thank you.